Good day everyone. In integration, I will teach you some important extra sums or models which are not in your textbook. Now let us see one sum now. I is equal to integral 0 to 1 cot inverse 1 minus x plus x squared dx. Now you should remember some inverse trigonometric formulae and concepts to do this sum. You know cot inverse x is equal to tan inverse 1 by x and vice versa. So this is one inverse trigonometric concept or formula which you have to remember now. So now I am going to write this as integral 0 to 1 tan inverse. Okay. Then write 1 by 1 minus x plus x squared dx. Okay. Why do I do like this? Actually, in your textbook, there is one some as a multiple choice, no, in the miscellaneous exercise where you have a tan inverse function and you have a similar thing, but you have some numerator there and that sum is a bit similar to this. So now the cot inverse I am bringing in terms of tan inverse using this formula. Now what I am going to do is I will write 0 to 1 tan inverse. First let me see the denominator. I will write 1 minus, I will take one x common, I will get x into 1 minus x, right? That is for the minus x plus x squared. I have taken minus x common, so I get 1 minus x. Now I am going to express the numerator 1 in terms of this x and 1 minus x. That 1 I will write it as x plus 1 minus x. Then I will get a dx. Okay, this step is the main step. Please listen to it carefully. What I have done? 1, I have taken a minus x common out. I get 1 minus x. The numerator I have 1. That I am writing it as x plus 1 minus x. Okay, now another trigonometry formula which you have to remember is tan inverse a plus b by 1 minus AB, that is equal to tan inverse A plus tan inverse B. Okay, this is another inverse trigonometric formula which you have to now remember. Now in the place of A I have x, in the place of B I have 1 minus x. So see, this one is satisfied here. So now I can write this as integral 0 to 1 tan inverse. Instead of A, I will write x plus tan inverse. Instead of B, I will write 1 minus x, then dx. Okay. So first what did you do? The cot inverse, you use this concept and converted in terms of tan inverse. Then the denominator, you took minus x common and you wrote it like that. The numerator 1 you expressed as x plus 1 minus x. Then you used another inverse trigonometry concept and you got like this. Now let me write it as two integrals. That is my I will be now equal to integral 0 to 1 tan inverse x dx plus integral 0 to 1 tan inverse 1 minus x dx, right? Now I have what? Two integrals. Now keep this first integral as it is. For the second integral alone, you use one property of definite integrals. So now I am going to write it as it is. Okay. Now for this integral, okay, I am going to use the property. I will write within bracket integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Using this property, I will get here 0 to 1 tan inverse 1 minus, in the place of x, I will get 1 minus x dx. Okay, so I am keeping one integral as it is. For the second integral, I am using this property. So here my a is 1. So in the place of x, I get 1 minus x. Now if you remove the bracket, 1 and minus 1 will get cancel each other. Minus into minus x, you will be getting plus x. So now what will I get? I is 0 to 1 tan inverse x dx plus integral 0 to 1 again tan inverse x dx, which I can write it as twice integral 0 to 1 tan inverse x dx. This is my I. Now, this is a very simple thing, you know. You can use integration by parts and integrate, but the 2 is there. So, to be on the safe side, I will write I is equal to 2I1. I mark this as 1 and my I1 is integral 0 to 1 tan inverse x dx, which I will be integrating using by parts. Then I will put that 2 also. Is it clear up to this to you now? If you see I1, that is a sum in itself, no? I1 is equal to integral 0 to 1 tan inverse x dx. So now we have to use integration by parts. Since you have only one term, that is your u function. So u is tan inverse x. Your dv will be equal to dx. Always whatever is inside, you will be writing it as u1 dv, right? Now you will differentiate this u. So I will get du is equal to 1 by 1 plus x squared dx. I will integrate here. I will get v is equal to x. Then the formula for integration by parts is integral u dv, that will be equal to uv minus integral v du. Okay, always the left hand side will become the I, and then uv is one part of the answer and the v du will be easily integrable for you. So now let us write. Here I will get now I1, that will be equal to uv. U is tan inverse x, v is x. So I write it as x tan inverse x, but this is definite integral. So put it, that you have to use for uv also. Then minus integral 0 to 1 v du. So x into 1 by 1 plus x squared dx. So this is the part which you have to integrate. So now I will substitute the limits at the same step for both these. So I am writing it as it is. Here I have x by 1 plus x squared. I know the differentiation of 1 plus x squared is 2x. So I multiply and divide by 2. That will make my integration easier. I will write 1 by 2 integral 0 to 1 2x by 1 plus x squared dx. Now the numerator is the exact differential of the denominator. Actually, if you substitute this as t, that will become dt. But you can straight away use it. F of x, this is like, no, this is your f of x, that is that 1 by 1 plus x squared, and this 2x dx, no, that is like your f dash of x. Then you can write the formula as log of this. So I will write x tan inverse x 0 to 1 minus half log mod 1 plus x squared within the limits 0 to 1. So now I have got both the terms. Now I can apply the limits. So for this one, when I put 1, this will become 1 and tan inverse 1 is nothing but pi by 4. When I put 0, this is 0. So 0 to anything is 0. So pi by 4 for the first part. Then I will write minus half, put a bracket, log 1 plus x squared, so 1 plus 1, that will be 2, minus log 1 plus 0 is 1. You know log 1 is 0, that you should remember. So you get only this. So the answer will be pi by 4 minus half log 2. This is the answer for I1. But you know your I is equal to 2I1. So I will be equal to 2 into, you will get pi by 4 minus half log 2. So you will get 2 into pi by 4, that will be pi by 2. This 2 and that 2 will go. So I will get pi by 2 minus log 2. Have you understood this? You subscribe to the channel and click the bell icon to get notifications of further videos. Thank you.